Welcome to Enots Engineering. I'm Alan. In today's video I'm looking at lathe turning tools. Here I have a set of tools from Bangood. There are 7 tools in the set. They come complete with the inserts, and my brother paid £14 for one tool at the engineering show. For the cost of probably 2, you get the whole set. So let's have a look what's in the box. So first of all, we have a packet containing an insert for each tool. Let's move this box away. I'll just take one at random. So the first one I have is this container with a tool in, and this is the tool number. Now if you put that in the internet or your web browser, you should come up with this tool, and it will tell you there how much the tool costs, how much the inserts are, and what the part number is of the insert. And I know you can buy inserts usually in a packet of 10. So let's have a look at this one. In the packet you get an Allen key or a star drive key, extra long one to put more leverage on. This one is a parting off tool, and the insert for that is this one here. You need the longer Allen key because you have to put a lot more load on the screw to hold the tip. This insert just slides in. On the bottom of the insert you have a groove that slides along the groove on the tool holder, holds it there, and you tighten the screw up. Now this is a 2mm wide insert, and we'll cut a groove 2mm wide or part off the end of a bar. I've fitted all the inserts in the holders, and now I'm just laying them out in order. So we have a parting off tool, turning tool for facing and turning the OD, another one just a different shape tip so you can get into a sharper corner, different angle, and then a straight one. I sometimes use this for chamfers. Then you've got your external thread cutting tool, your internal thread cutting tool, and a standard boring tool. The thread cutting tools have 3 cutting points on each tool, so you can rotate the tip when the tip gets blunt, and the other tools have just 2 cutting edges. So let's go into the workshop and take a closer look. We can see on there it says SD JCR 1212 HO7, and this one is a similar tool that I already had just to compare, and it's SD JCR 1010 HO7. So one's a 10mm square tool and the other one is a 12mm square tool, and they take the same carbide inserts in both. The only difference between the two is the thickness of the body. So if you've got a smaller lathe you could get the 10mm tools, 12mm tool, and they also make a 16mm tool. I've placed the tool in the tool holder, and now I'm going to adjust the height. I'm just putting the tip of the tool under this lock the tool post, then lift the tool up until the dial indicator moves, and now I know that's on centre line. Just lock the tool, turn it round for cutting. Just place a piece of steel in the chuck. Now I want to run this at the fastest I can. That's running at 1000 RPM. Make sure everything's tight. I'm cutting this by hand, and if I was to use a traverse, I'd get a lot better finish. You can see the sort of finish you get. So when you're cutting with tungsten carbide inserts, they will probably cut twice as fast as high-speed steel. If I was using free cutting mild steel, I'd get a better finish. You can put a deeper cut on and the tool will take it. And the only problem you have is the tool will get hot, so you need to keep the tool tip cool. I don't have coolant on this machine. The only way you can keep tip cool is by using maybe a paintbrush and some cutting fluid on it. Inserts are made from tungsten carbide powder, cobalt and other additives including titanium. When they're moulded, they're twice the size of the finished insert and shrink in the sintering oven. They're then ground with a diamond wheel to give you the cutting edge. And that's a 7-piece turning tool set from Bangood. Hope that was useful, hope you enjoyed it, and we'll see you next time on Enots Engineering.